Okay, so for this problem set, I chose the first problem, acute angles problem. Point P is chosen at random inside an equilateral triangle ABC. Find the probability that one of the triangles ABP, APC, and PBC is acute. So first, I'm going to construct a triangle. So we're going to go up here, regular polygon. Okay, and that makes an equilateral triangle. And next, I'm going to do a random point. So, random. We're going to scroll down to this random point polygon, and this is poly 1. Okay, so there's the random point in the polygon. If you push Control R, it'll just move around. Okay, so we're going to make 3 triangles with this point. So, bam. Okay, so now when you push Control R, those triangles move. Trying to get it to a place where, there we go. So now we're going to look at the angles inside the triangle. Okay. And so the problem is we want to find the probability that one of the triangles is acute. So we're trying to find if one of these angles are acute. So we're going to put down here is acute if, so it's alpha is less than 90 degrees. And then this is the or sign. Okay. So if we look at is acute, it says false right now because all of these are more than 90 degrees. So if we change it a little bit, it's true. Because if you see right here, this one's less than 90 degrees. So we're trying to figure out when this is true. So I'm going to open a spreadsheet and I'm going to record these values to spreadsheet. And I want to trace to list because that's going to help me add it all up. Okay? So if we look at this, it's recording for me. That's exactly what I wanted because it's going to help me figure out the probability. But I don't want to go through and add all these up by myself. And so since I have all of them recorded in A1, I'm going to do the sum of A1. And so up here, that is now a variable. It's a value now, so I can see it. And when I do Control R, it moves. It changes with the changes in the triangle. Okay. And you know, it's all cool to have the sum and everything. So right now the sum is 49 and I've done 78 trials. But I want to know the probability, and that's going to be with the average, which is the mean. And so it took me a while and I pondered, you know, how should I get this? But it's actually pretty simple. I just did the mean of A1. And there we go. It's a variable also, and it changes. And so what I'm going to do is, we're at, you know, 108 tests. I'm just going to, you know, push Control R and just leave it until I get maybe around 1,000 trials, and then I want to see what the probability is. I'm actually going to rename that probability so it's easier for people to see what it is. And while I'm at it, I might as well change you to sum. Okay. So I'm just gonna see where it ends up, because the more trials you have, the closer to the actual probability you're gonna get, because you're adding more trials, so you're adding more data. And so the more data you have, the more accurate you'll be. So we're just gonna go. And you can watch it change up there. Right now it looks like it's staying around the 0.6, 0.61. Still around there, 0.62 now. Back down to 0.61. And 0.62. Okay. So we're at 0.6. It's, you know, when we first started it was higher, and then it went lower, and then kind of like bounced higher a little bit. But for the most part, it seems like it always goes back to 0.6. And doesn't really go below that. I'm just gonna see maybe a little more, see if it changes at all. But it's not. It's looking pretty steady now, at 0.6. So I'm concluding that the probability is 60%, 0.6. Yeah.